MTH 1200, week 5, lesson number 2. And keep in mind, we are keeping it a little short so you can get a good head start on your project. The lessons that I'm going to upload for Wednesday are going to be longer than these first 2. So you should get a good start on your project. It's only 5 questions, but they're pretty deep. You should get a good start on that before Wednesday, because then you're going to get a couple of longer lessons to work on. Now, what do we got today? Heavy review. We talked about that before. No new material with these 2 lessons in week 6. Homework answers, do it, review, and some more quadratic equation word problems. Here's your homework answers. There were only 3 questions. Take a good look at them, because there's some challenging algebra in number 1, and number 2 is pretty straightforward word problem, and then number 3 is a little more involved word problem. So take a look at these 2. I will be quiet now, and you can do stop and start. As always, any questions, reach out to a classmate or myself. And of course, you may figure out what your mistake was by looking at the work shown. And here's the last one. A couple of words on this one, because we haven't done anything like it. You've got a garage and a house. The garage, we know that the house, each side is 6 because they're shaped in a square, longer than the garage. So if we let the garage side of a square of that would be x, then the house is x plus 6. And the area of the garage is x squared, because length times width. And then the area of the house is x plus 6 squared, which you have to remember to do means x plus 6 times x plus 6. And then it says if the combined areas are 180. So x squared plus x plus 6 squared is 180. And then you start following the algebra. You might want to pause now and do that. And you get to the point where you come out with x squared plus 6x minus 72 is 0. That's x plus 12 times x minus 6. And the answers work out to the possibilities of negative 12 and 6. But we reject negative 12 because this represents a length. So the dimensions of the garage are 6 by 6 and the house is 12 by 12. All right. And let me escape here. And I cannot believe that this isn't on animations here. And let me just check and see if that's true for any of the upcoming ones. Well, that's just praxis. That's pretty straightforward. That's animations. Oh, and there's the recap. All right, so you got a peek ahead as to what we will be doing today. Today's do it is this question. And let's go to slideshow and play from current slide. Okay, there you go. So if you happen to peek at the answer before, don't go back and look at it. Have you solved this on your own? This is a nice question, okay? Not killer hard, but a little more challenging than usual. You can do stop and start. I'll start up soon. Okay, so the product of the ages of Alan and Terry is 80, more than their ages 4 years prior, the product of their ages. If Alan's 4 years older than Terry, now what are their current ages? So the ages today, Alan is X, Terry is 4 years older. Oh, Alan should be 4 years older. So let's correct this again. Ready? And there we go. And play from current slide. Okay, give that a shot and get it started. I will be back in just a couple of seconds to finish it up with you. Just a couple of seconds. Sorry, had a little minor emergency. and it's insane to go back and start the videos all over again. So we'll just resume from this point, and I hope you forgive me for that little brief interruption. Okay, so ages today, Alan and Terry. Alan is 4 years older than Terry. So Terry is X, Alan is X plus 4. What are their current ages? Well, the ages 4 years ago, Terry would be X minus 4. Of course, I didn't adjust that one. I should have. Okay. And Alan would be X. So I would have lost a little bit of credit on this because I messed up the names. But I would have gotten almost full credit because I'm doing the work properly. So today, Alan's 4 years older than Terry. So if Terry's X, Alan's X plus 4. 4 years ago, I have to take 4 years off each person's age. So 4 years ago, Terry was X minus 4. And Alan, if he's X plus 4 now, and then I take away 4 years, it's going to be just X. Now, it says the product of the ages today is 80 more than the product of their ages 4 years prior. So if I do their ages today, which is X times X plus 4, I have to take the product of their ages prior, which is X times X minus 4 plus 80. Product of the ages today is 80 more than the product of 4 years ago. So X times X plus 4, that's today, is years ago, X times X minus 4 plus 80. Do some algebra. Distribute X squared plus 4X equals X squared minus 4X plus 80. Look at that. We can subtract X squared from both sides and get rid of the squared term. Makes it linear. How nice is that? 4X is danger, danger, danger. Peek in front of that 4X. It's a negative. Negative 4X plus 80. Add 4X to both sides. 8X is 80, so X is 10. So today, and I forgot to switch it on the last one, Terry is 10, Alan is 14. Praxis power. Performance is a function of preparation. Let's do, I think it's 4 questions about that relate to praxis and see how you do. The cool thing is a number of them relate to things we've done already in the course. Let's try this one. Of course, you're doing stop and start. So, if you increase by 25%, the old budget, which was at 100%, then you increase it by 25%, you get to 1,500. So if you do a 25% increase of a budget that was the whole budget, which is 100%, the original budget, if I add them up all together, that's 125%. And as a decimal, it's 1.25. So if I take 1.25 times the original budget, call it B, it's going to be 1,500. Divide by 1.25, and I get B is 1,200. Ta-da! There it is. Hopefully you got that right. We've been doing just little bits of percent problems as they go along because it seems that the praxis tests have a handful of percent problems on them. Okay, now the next one. Apparently I didn't put an animation in here. Animation, fly in. Okay, let's go to slideshow and here. Okay, here we go. Which of the following expressions has the same value? Figure it out. Stop and start. Okay, so what I realize is that the correct answer is going to be E, because a great way to do this on the graphing calculator is by entering each choice. So if you have access to a graphing calculator on the test, and I hear that some sections do, you can go into y equals and you can put the questions expression and then each of these choices one at a time. And if the two tables look exactly alike, then you'll always have the same value. If you don't want to do it that way, do it algebraically, you can distribute the 4 to both terms and then divide by the 2. And if you do that, remember dividing by 2 is the same thing as multiplying by a half. That's choice E. Distributed the 4 and then multiply by a half. Okay. Turn the following sentence into an algebraic equation. The tax on a $400 game system is $34. T represents tax as a decimal. Go ahead. Okay, so the big understanding here is that when you do tax, you multiply because it's the percent of the cost. So of in mathematics is multiplication. So that's going to be choice C, 400 times the tax is going to be 34. Okay. Which of the following is the correct factorization? Look at this, a praxis problem, and we have to do some factoring. Go ahead. Okay, so first I look for a common factor. There is none. So I'm going to do the multiply the lead coefficient by the last term, and that gives me x squared minus 7x plus 12, right? Because 6 times 2 is 12. Factor that, x minus 4 times x minus 3. But now I have to remember to go back in and divide by 6. That's what I'm doing here. Then reduce each fraction, and I get x minus 2/3 and x minus 1/2. If you're stuck, your calculator can help you reduce a fraction. And then in each case, you have to put that 3 out in the front there like an improper fraction. 3x minus 2 times 2x minus 1. I don't even need the equal 0. I don't know why I put it there. That was a mistake. And that would be... Oh, I kept going. But it's 3x minus 2 times 2x minus 1, which is choice B. I made a careless mistake here. I kept going for it equaling 0. As if it was an equation. It wasn't. It was just the correct factorization. I could have stopped at 3x minus 2 times 2x minus 1. Choice B is correct. Okay, now we get into 3-word problems, all of which involve some geometry here. So let's do this one. Stop and start. Okay, so always a diagram with geometry, always underline the important stuff. Rectangle, 5 feet more than twice its width, wants the dimensions, if the area is 168. So here is my rectangle. Length times width is area, so W times 2W plus 5 is 168. Distribute. 2W squared plus 5W is 168. Get it all on one side, minusing the 168. No common factor here. Got to do my multiply by 2 thing, where I take the lead coefficient and I multiply it by the last term. That gives me W squared plus 5W minus 336. And I factor that, I get W plus 21, W minus 16. I did that one on the calculator. I don't have these numbers off the top of my head. So there are times and places where the graphing calculator is critically important. Now, divide both by 2, and I get 2W plus 21 and W minus 8, because 16 over 2 breaks down to 8. That's going to equal 0. I get W is negative 10.5 and W is 8. I reject the negative 10.5. 8 is the width, and the length is going to be 2 times 8, 16 plus 5. So 2 times 8 plus 5 is 21. So the width is 8 and the length is 21. I forgot to change that from the previous question. Okay, here you go. Right triangle problem. We've done, I think, 3 of these already, maybe 4. Go ahead. In fact, I think it was 4. Okay, so leg squared plus leg squared is hypotenuse squared. X squared plus x plus 4 squared is 20 squared. X squared plus x plus 4 times x plus 4 is 400. X squared plus 8x plus 16 is 400. That gives me 2x squared plus 8x, subtracting the 400 minus 384 is 0. Let's get rid of that 2 because they all share it in common. Divide everything by 2. Gives me x squared plus 4x minus 192. And again, I don't walk around with factors of 192 off the top of my head, though I can get it if I need to work it out. And calculator is quick and easy for everybody. So that's x plus 16 times x minus 12 is 0. Since I only divided out the 2 by everything, so I don't have to worry about bringing the 2 back in. X plus 16 is 0, or x minus 12 is 0, so I get negative 16 and 12. Reject the negative 16. 12 is the one leg. 12 plus 4 is 16 is the other leg. And the area is half of the 12 times 16, which is 96 centimeters squared. Okay? Let's try our last new problem of the day. Go ahead. So I would call this pretty straightforward. There is my rectangle. The only thing that's a little different about this is it's x minus 10 for the width. Usually we make the length longer. This time we made the width shorter. Length times width equals area. So x times x minus 10 is 200. Distributing, x squared minus 10x is 200. Get it all on one side. X squared minus 10x minus 200 is 0. Factor, x minus 20, x plus 10 is 0. Maybe it's the guy on the left. Maybe it's the guy on the right. Adding 20, subtracting 10. This is a length, so I reject the negative 10. I keep the 20, and that means the lengths are 20 for x up here and 20 minus 10. 10 for the other one. Okay, those are some nice examples of quadratic applications in the real world, which is, I think, 40 points on your project. The happy recap for today. Today's mostly review, a chance to assess for yourself any areas you might need to address. Remember, if you have issues, Monday nights, 7 o'clock to 9 o'clock, just send me an email ahead of time and let me know that you plan on attending, and we'll set up a time. Word problems, underline anything important and use it. Check it off as you do it and go along. Quadratic equations, for now, get everything on one side and factor. Evaluate if the possible answer fits the situation. For example, it's come out to be a negative with lengths? Can't be. Reject it. Make sure you get your project in on time. Don't forget about that. That's real important.